UN 영어뉴스 Why finding alien life in universe is now only a matter of time. Europa, one of Jupiter's icy moons, is the most likely place in our solar system to be home to alien life. Many astronomers are no longer asking whether there is life elsewhere in the universe. The question on their minds is instead, when will we find it? Many are optimistic of detecting life signs on a faraway world within our lifetimes, possibly in the next few years. And one scientist leading a mission to Jupiter goes as far as saying it would be surprising if there was no life on one of the planet's icy moons. NASA's James Webb Space Telescope (JWST) recently detected tantalizing hints at life on a planet outside our solar system, and it has many more worlds in its sights. Numerous missions that are either underway or about to begin mark a new space race for the biggest scientific discovery of all time. We live in an infinite universe with infinite stars and planets, and it's been obvious to many of us that we can't be the only intelligent life out there, says Prof. Catherine Heymans, Scotland's astronomer royal. We now have the technology and the capability to answer the question of whether we are alone in the cosmos. The Goldilocks zone telescopes can now analyze the atmospheres of planets orbiting distant stars for signs of chemicals that on Earth at least can be produced only by living organisms. The first flicker of such a discovery occurred earlier this month with the possible sign of a gas that is produced by simple marine organisms on Earth in the atmosphere of a planet named K2-18b, which is 120 light years away. Artwork K2-18b orbits a cool dwarf star, shown in red, just far enough away for its temperature to support life. The planet is in what astronomers call the Goldilocks zone, the right distance away from its star for the surface temperature to be neither too hot nor too cold, but just right for there to be liquid water, which is essential to support life. The team expects to know in a year's time whether the tantalizing hints they have obtained are confirmed or have gone away. Prof. Niku Madhusudan of the Institute of Astronomy at Cambridge University, who led the study, told me that if the hints are confirmed, it would radically change the way we think about the search for life. If we find signs of life on the very first planet we study, it will raise the possibility that life is common in the universe. Even if they don't find life signs on K2-18b, the team has 10 more Goldilocks planets on their list to study, and possibly many more after that. Prof. Madhusudan predicts that within 5 years there will be what he describes as a major transformation in our understanding of planetary habitability and life in the universe. By then, we will have had the chance to study half a dozen planets like K2-18b or ones that are slightly hotter. It is possible that we are close to having the first detection. On the other hand, having no detection on any of them would also provide important insights into the possibility of life on such planets. But as powerful as JWST is, it has its limits. Earth's size and proximity to the Sun enable it to support life, but JWST wouldn't be able to detect far-away planets as small as Earth. K2-18b is 8 times bigger, or as close to their parent stars, because of the glare. So NASA is planning the Habitable Worlds Observatory (HWO) scheduled for the 2030s, using what is effectively a high-tech sun shield. It minimizes light from the star which the planet orbits. That means it will be able to spot and sample the atmospheres of planets similar to our own. Artwork: The Habitable Worlds Observatory places a sun shield in front of the star to see the planets around it more clearly. Also coming online later this decade is the Extremely Large Telescope (ELT), which will be on the ground, looking up at the crystal clear skies of the Chilean desert. It has the largest mirror of any instrument built, 39 meters in diameter, and so can see vastly more detail at planetary atmospheres than its predecessors. All three of these atmosphere analyzing telescopes make use of a technique used by chemists for hundreds of years to discern the chemicals inside materials from the light they give off. But JWST, HWO are so incredibly powerful that they can do this from the tiny pink prick of light from the atmosphere of a planet orbiting a star hundreds of light years away. How light reveals a planet's atmosphere. 1. Light can be split to reveal different wavelengths. Light, star, light, instrument, long, short. 2. Some light passing through an atmosphere is absorbed. Planet's atmosphere. 3. The missing wavelengths tells us what is there. Water, carbon dioxide, carbon monoxide. Close to home, while some look to distant planets, others are restricting their search to our own backyard, to the planets of our own solar system. The most likely home for life is one of the icy moons of Jupiter, Europa. It is a beautiful world with cracks on its surface that look like tiger stripes. Europa has an ocean below its icy surface, from which plumes of water vapor spew out into space. Europa's tiger stripes are caused by cracks on its icy surface. NASA's Clipper and the European Space Agency ESA's Jupiter Icy Moons Explorer JUICE missions will both arrive there in the early 2030s. When I asked Prof. Michel Dougherty, who is the lead scientist of the European mission, if she thought there was a chance of finding life, she replied, "It would be surprising if there wasn't life on one of the icy moons of Jupiter." NASA is also sending a spacecraft called Dragonfly to land on one of the moons of Saturn, Titan. It is an exotic world with lakes and clouds made from carbon-rich chemicals, which give the planet an eerie orange haze along with the water. These chemicals are thought to be a necessary ingredient for life. A view of Titan taken by ESA's Huygens lander as it descended to its surface. Mars is currently too inhospitable for living organisms, but astrobiologists believe that the planet was once lush with a thick atmosphere and oceans and able to support life. NASA's Perseverance rover is currently collecting samples from a crater thought once to have been an ancient river delta. A separate mission in the 2030s will bring those rocks to Earth to analyze them for potential microfossils of simple life forms that are now long gone. These are just some of the many missions that are on the way or planned for the coming years, searching for signs of life on the planets in our solar system. Others looking much further into deep space, hunting for life across the universe. How scientists are searching the solar system and beyond. Now, late 2020s, early 2030s, mid 2030s. Deep space SETI scanning for broadcast. Extremely large telescope analyzing atmospheres of planets, Mercury, Venus, Earth, solar system. James Clerk Maxwell telescope scanning the clouds of Venus. James Webb telescope analyzing atmospheres of planets. Habitable Worlds Observatory analyzing atmospheres of planets. Mars. ExoMars rover drilling planet surface. Mars return mission bring samples to Earth. Tianwen-3 bring samples to Earth. Europa, Jupiter. Jupiter Icy Moons Explorer JUICE is investigating if Moon could support life. Titan, Saturn, Uranus, Europa Clipper investigating if Moon could support life. Neptune, Dragonfly looking for signs of pre-life chemistry. Intelligent life. Could aliens out there somewhere be trying to reach us? Some scientists consider this the realm of science fiction and a long shot. But the search for radio signals from alien worlds has gone on for decades, not least by the search for extraterrestrial intelligence SETI Institute. All of space is a large place to look, so their searches have been random to date. But the ability of telescopes such as the WST to identify the most likely places for alien civilizations to exist means that SETI can focus its search, and that has injected fresh impetus, according to Dr. Natalie Cabral, director of SETI's Carl Sagan Center for the Study of Life in the Universe. SETI's Allen Array of Radio Telescopes. The institute has modernized its telescope array and is now using instruments to look for communications from powerful laser pulses from distant planets. As a highly qualified astrobiologist, Dr. Cabral understands why some scientists are skeptical of SETI's search for a signal, but chemical signatures from faraway atmospheres, interesting readings from moon flybys, and even microfossils from Mars are all open to interpretation. Dr. Cabral argues, looking for a signal might seem the most far-fetched of all the various approaches to find signs of life, but it would also be the most unambiguous, and it could happen at any time. Imagine we have a signal that we can actually understand, says Dr. Cabral. 30 years ago, we had no evidence of planets orbiting other stars. Now more than 5,000 have been discovered, which astronomers and astrobiologists can study in unprecedented detail. All the elements are in place for a discovery that will be more than just an incredible scientific breakthrough, according to Dr. Subhajit Sarkar of Cardiff University, who is a member of the team studying K2-18b. If we find signs of life, it will be a revolution in science, and it is also going to be a massive change in the way humanity looks at itself and its place in the universe.